In this video, we are going to discuss on Eulerian graph. Now, an Eulerian trail or Euler walk in an undirected graph is a walk that uses each edge exactly once. If an Euler trail exists in a given graph G, then G is called a traversable graph or a semi-Eulerian graph. Now, this is an example of an undirected graph. When we say undirected graph, there is no specific direction as to from which vertex are we going to start and then going to the next one. So there's no exact direction. Unlike for directed graph, we have to follow the direction that is indicated by the arrow. So in this case, from vertex 1, we have to go either to 3 or to 2, vertex 2. And then, if we went from vertex 1 to vertex 2, then after that, we have to go to vertex 4. Then after vertex 4, we have to go to vertex 3. Then vertex 3, we cannot go back to vertex 1 since there's no direction pointing that we can go from vertex 3 to vertex 1. So that's the difference between undirected graph and directed graph. Okay, so let us identify if the given graph is a semi-Euler or semi-Eulerian graph. Now take note that a semi-Eulerian graph is an Eulerian trail or an Euler walk, meaning we are going to use all the edges exactly once, but since it is a trail, so it's not necessary that we will go back to our starting vertex. So to which vertex we have started, it's not necessarily that we will end up in the same vertex. So let's say for example here, so the trail is, let's say I want to start at D, so D, then I'll go to C, then I'll go to B, okay. D, DC, then CB, then BD, BD, then from D I'll go to A, then from A I'll go to B. So I have used all the edges of the graph exactly once. So meaning, and then it's not necessarily that I have to go back to D, in which this is the vertex where I started. So I end up at B. Okay. Now, as you have observed, I used the vertex D twice. I used vertex D twice. And it's okay because it's not part of the condition here. Okay, there is no condition stating that we cannot use the vertex more than once. Okay, the only restriction is the edge. Okay, the edges only. So this is an example of a semi-Euler graph. Now this is Eulerian graph. An Eulerian cycle or Eulerian circuit or Euler tour in undirected graph is a cycle that uses each edge exactly once. If such an Euler cycle exists in the graph concerned, then the graph is called an Eulerian graph or a unicursal graph. So if in semi-Eulerian graph, we have the conditions are we have to use all the edges. We have to use all the edges of the graph. More than not we need to use all the edges of the graph once, and it's not necessarily that we have to go back to our starting vertex. Okay, in this case, and also we can in semi-Eulerian graph we can use the vertex more than once, as long as the edges we will use it only once. Okay, now in Eulerian graph we have same nodes, they have quite similar conditions. We have to use all the edges exactly once, but since an Eulerian graph is an Eulerian cycle or circuit, therefore we have to go back to our starting vertex. It means that our starting vertex and our end vertex should be equal, should be the same. So for example here, so if we will start at 2, so our circuit will be 2 to 0 to 4 to 3 to 0 to 1, then we will go back to 2. So this is our circuit 2 0 4 3 0 1 2. So this is an example of, and although we are also allowed to use the vertex more than once, as long as it is important that the edges that are incident to this particular numbers, we'll only use them once. Okay, the edges that are incident to 0, we will only use them once. Okay, so that's Eulerian graph and semi-Eulerian graph.